Okay, so as we look at higher ordered polynomials, this applies to quadratics too. The important part of this graph, this little summary, is if it's the leading coefficient is positive, the right side goes up. If it's negative, the right side goes down. If it's even, the left goes the same way. Your ends are going in the same direction. If it's odd, they're opposite. That means if the right is up, the left is down. We don't use all these words in math, though, do we? We say, as x approaches positive infinity, this is the right side. As x approaches negative infinity, that's the left side. That's how we say right and left in math, right? Then we say y goes, so if it's even, these two are going to be the same, right? Now as x goes to the left side, so notice, let's circle those. If they're even, those are the same. If they're odd, these two are opposite. And you're familiar with this notation. You've been practicing that for a long time, but it makes it really fast to write it. As soon as you figure out what the right side is doing, you know what the left side is doing, right? If they're even, it's going the same way. If they're odd, if it's cubed or to the 5th power, then it's going the opposite direction, right? Turning points. A polynomial function has a degree of n, let's say x to the 5th. That means it's going to have n minus 1, or, for example, y equals x to the 5th has at most 4 turning points. Now, does it have to have 4? Can it have less than 4? Yes, it can have less than 4. This tells you maximum. The most it can have is 4. That helps you to graph stuff. It helps you to identify. If you had a lineup of graphs and you had to identify which one goes with which, these are all the clues you can use. It's kind of like identifying someone, saying, well, they have brown curly hair, they were 5'8". This is a description of your graph so you can figure out who it is, okay? So identify whether each function has an odd or even degree and a positive or negative leading coefficient. Well, the ends are going opposite directions, so what does that tell you about the degree? It is odd. The right side goes up, so the leading coefficient is what? Positive. Put in there, right side up. Really, really important that you know this. Okay. End behavior. Now, is this top one the left side or the right side? That's negative infinity, so that's the left side. This is positive infinity, so that's the right side. So as x goes to the left, where does y go? Is it going up or down? Well, we're going down, so that's negative infinity. The right side is going up, so that's positive infinity. You always have to look to see which one. Sometimes people will write the positive side first, so always be on the lookout. Okay. The right side goes up. So what's the leading coefficient? Positive or negative? Positive. Both ends are going the same way, so the degree is even. What about this one? Ends are going opposite directions, so the degree is odd. And the leading coefficient, it's going down, so it's negative. Does that make sense? Right here, as x approaches negative infinity, again, we're looking at the left side. And we could see both ends go the same way. On this one, it's odd, they're going to be opposite. So the right side is going down, left side's going up. Any question about that? You've done that a million times and looked at that. It's not too bad, right? All right. How important is this page? Very important. You have to know that page, right? So that is memory. Must know that stuff. All right, what's next? Multiplicity. What does multiplicity mean? First of all, I'm going to make up a crazy problem. Okay. What's the multiplicity of these? This is a 1, so it's got a multiplicity of 1. This is squared, so it has a multiplicity of 2. This is cubed, so it has a multiplicity of 3. Multiplicity is very important. If it's odd, that means it crosses the x-axis there. If it's even, that means it touches. And we're going to go over this in a second. Bounces. You know, like it might go turn around, it bounces, it doesn't cross. We're here. It's going to cross over, right? The proper word for that is to say that it's tangent. But when we say touches or bounces, we know what that means. 3 is odd, so it crosses. Okay, does everyone see where the multiplicity comes from? It's that exponent. Okay, so let's see what we wrote down here. The multiplicity of a root is the number of times that x minus r is a factor. In other words, x minus 3 squared or whatever. The graph of an odd multiplicity crosses. So let's highlight that or put a color. Where it's odd, we're going to cross, right? Where it's even, we're going to bounce. And that's actually called tangent. As you get fancier, that's called tangent. Does that make sense? This tends to be a subject that people don't like. Multiplicity always scares people, so I don't want you to be scared. Does anyone have a question about what multiplicity is? Even, bounces, or is tangent or odd, crosses the axis? That helps you to draw and sketch stuff because you're like, oh, it's squared, it's going to turn around. It also helps you identify curves, right? Okay, example 1. Find without using a calculator, then graph. Okay, so first of all, this is odd, correct? So we know ends go opposite directions. Is the leading coefficient positive or negative? It's positive. Therefore, I know the right side, which is this one, goes up. And if it's odd, that means the left side is the opposite. Very easy to tell, right? Not hard. Maximum number of turning points. It's cubed, so the maximum number is 2. F of 0. What do you get when you plug 0 in for x? -3. When someone asks you, sometimes we don't recognize this. When you see f of 0, what are they really asking you for? Yes. Notice that that's the y-intercept. So I'm going to put so the y-intercept is -3. That helps me graph. Now I need to find my zeros. How does one go about finding zeros? Factor. We got to factor, right? That's always the easiest way to do this. So how do we factor when we have 4 terms? We group, right? Now, if you group and there's a minus sign right here, what do you have to do with this sign? You have to change it, right? Because we put parentheses, now it's distributed. Okay, what can we factor out of x cubed and 3x squared? What can we factor out of this? X squared? And then it's going to be x plus 3. Now, if you have a factor like x plus 3, and we can't factor anything out, what can we factor out? A 1. I'm not going to put the 1 for a second. I want to show you. Well, no, I am going to put the 1. The reason I write a 1 down is you got to pair guys up now. These two factors should match. And if they do, you can pull them out. So what we get is x plus 3 times these two guys. Oftentimes when people don't pull a 1 out, they just write x squared down. They forget that there's a 1 there. So it's to your advantage to pull that 1 out. Now, can we factor this further? X plus 1, x minus 1. So where are the zeros? At -3, -1, and 1. What is the multiplicity of each one of those zeros? Well, that's to the first, this is to the first, and this is to the first. So the multiplicity is 1. What does that tell you at each of the zeros? We're going to cross the x-axis. See, we don't have a lot of scary work to do. So we have a 0 at 1, -1, and -3. And which way is our arrow pointing? It's pointing up. So it makes it very easy to graph this. Now, do I know how high this hill is right there? I don't. Did they ask me to find that? No. Could you if I said, hey, you got to find that? Well, if this is 1 and that, if this is -1 and this is -3, where's the maximum? At -2? If you had to, could you plug -2 into the equation and find y? You could, but you weren't asked to, so it doesn't matter, right? Okay, example 2, we're going to get the calculator and use that. Any questions over example 1? Is that easy? You got to find your zeros. That's the key part, right? Are you an expert factor? You are. You're charged with being an expert at factoring. If not, please see me. All right, so we're going to put this one in. Well, okay. Let's see if this holds out. We practiced this the other day, so we're going to graph it. Oh, my graph is messed up, right? So I'll do a zoom 6 and put it back. Now, something I would always do before I graph is I would look for zeros. I would go to my table and say, I can always find the y-intercept, right? And then I can look here and see if there's any zeros, and there's not. That means they're all decimals. So how do we find those? Second calc, 0. Now, 1, 2, 3. I can see there's one between -5 and -3. So I'll type in -5 is on the left, -3 is on the right. And yes, I'd like to guess. So that is -4.064. Then we'll find the other one. So take a second, get on your calculator and make sure you find your zeros. That one's between -2 and 0. And the last one. You have to find each zero. So this one's between 0 and 2. Okay, there we go. I have a 0, just a smidge bigger, and then right there, and right there. And it is positive in the front, right? So multiplicity of each one of those is 1. Does that make sense? Are we okay? Y'all are good with your calculator? No troubles there? Okay. All is good. All is good, y'all. Okay, here we go. Here we go. Okay, is this odd or even? Well, it's squared and it's cubed, so it's going to the fifth, so this is odd. Right? Now, is it positive or negative? Look at your x's. Are any of the x's negative? No, so the whole thing is positive. So we know that the right side goes which way? It's positive. So the right side goes up. And if it's odd, this is going to be the opposite. Everybody okay with choosing the maximum number of turns? Turns is 4. All right, let's list. I want right here what I've made a chart for is so you would make sure that you know what the difference is in the vocab. So the factors are x plus 2, x minus 3. The zeros, what are the zeros? X equals -2, x equals 3. I want to make sure you can get zeros out of factors and that the vocab makes sense. The multiplicity, well, this one is squared. This one is cubed. What does squared mean? It touches, bounces, if you like that word, or that it's tangent. Those all describe the same thing. This one is multiplicity. I'm going to write even. So you connect the dots that even and odd are what's determining this. It crosses. So let's see from those clues if we can sketch. So right here at -2 and there at 3. The right side is going up. So I'm up. Now when I get to 3, am I going to cross or touch? I'm going to cross. And then somewhere around the middle, I have to turn around. Now, when I get here to the -2, am I going to touch or cross? I'm going to touch, bounce. See how easy that is to get a rough sketch? Now, we could plug 0 in for x and find the y-intercept. I'm not interested in that right now. I'm interested in knowing if you know that zeros cross or touch. That y-intercept is going to be quite big, right? We're going to have 4 times -27. The y-intercept is going to be far down, but that's not what we're looking for. I want to know if you can cross or touch. Make sure that you can attach these descriptions. So even bounces. You know, I would color code these in my notes. Odd crosses, right? Make that connection. That's a major connection. All right. This is a little more practice with that. Sketch a graph of the function described and then write an equation of the polynomial function with the given characteristic. X crosses the x-axis at -3, -1, and 1, lies above the x-axis between -3 and 1, lies below the x-axis between -1 and 1. So all they want you to do on a question like this, you don't have to worry about y, we're just sketching so we know we've got -3, -1, and 1, right? So it crosses at -3, -1, and 1. So I know it's going to go through them. Is above the x-axis between -3 and -1. So we're above here. So now I know I cross at each one. So I can be pretty quick about getting sketch. Okay, what about this one? Touches the x-axis at 0, crosses the x-axis at 2. Okay, it's a degree of 3, so it's x cubed. So lies above the x-axis to the left of where x is 0. So there's 0, we're above. So now I'm going to be here and here. So I touch at 0. So I turn around, and now I have to cross at 2. So I have to pull it back down and go through 2. Are we interested in how high we draw that hill? We're not. What I'm trying to see is, can you get the ends pointed in the right direction? Okay. One little last review. Where are the x-intercepts here? So if they say x-intercept, that's what? Negative 2, 0, 1, 0, 2, 0, right? Maybe we should match these up. I'll color that one green. Right. I'll color this one purple if I'm worried in my notes, if I need to make good notes. You can always color code. Where are the zeros? People always come up to me on a test and say, isn't that the same thing? And I'm like, that's what I'm asking you. It is the same thing. It's just x-intercepts should have the 0 with them. Even if your software allows you to type if it says x-intercept, if it accepts this, and some of them do, MATLAB is bad about that, I want you to know that intercept technically means location. The factors, if negative 2 is a 0, what's the factor? X plus 2, right? If 1 is a factor, that's x minus 1. And if 2 is a factor, that's x minus 2. And what is the y-intercept? 1, 2, 3, 4. Again, I want you to know an intercept as a location, even if software lets you do other stuff. Does that make sense? I think that's it for today. It is it.